Our second example is data exploration with a quantitative data set. So for this example, we are going to look at things like data classification. We'll also look at table joins here, so you can see how that all works together. Here we are looking at data for, well, right now we're just looking at census cartographic boundary files for United States states and outlying territories. So we can see the lower 48, Alaska, Hawaii, Puerto Rico. If we went further, we would see the Virgin Islands and American Samoa and everything else. For the sake of simplicity and for your view, I'm just going to zoom in on the lower 48, but we'll definitely go out and look at Alaska and Hawaii in a minute. All of this came right from the census website, and I'll have that posted there as well. The quantitative data that we're looking at is the average number of participations in free school lunch programs. So this is data prepared by the U.S. Department of Agriculture, where all the students on average in a year in a state that had accessed the free lunch programs at public schools. So we can see we have 5 years of data, 2017 through 2021, and I wanted to kind of compare 2020 to 2021, or to compare back in history and see what is going on. So we see a lot of numeric data here, or a lot of numbers here, so let's go ahead and start getting that to display on the map by joining it to the state's attribute table from the census. So right now it's just the state's information, nothing about the school lunch participation. So we'll right click and go to joins and add a join. Our input join field will be name, and it will link to our state territory name in our attribute table. And how did I know how to do this? Looking at both attribute tables together and seeing if there was a common field. I was hoping for state names, but I would have taken if there was an ID number, a UPS abbreviation, whatever we had, so the FIPS number. We looked at, we can just use names. So we'll go ahead and keep all target features and click on Run. The book is going to make you index things, but we're okay. Oh, I already joined it. So we can see now that we have it joined, we can scroll to the right in our data and see our fiscal year 2017 through 2021. Now let's just say we wanted to start by just exploring this data, understanding raw counts of who accessed the school lunch programs. Let's see if we can, or what it looked like across different states. Kind of tricky to get them all in. So we go to graduated colors. We're going to keep it simple with a choropleth map. Change it from single symbol, try again, to graduated colors. There we go. And your instinct should be to go to field and change it to our fiscal year data. But if you notice, our fiscal year data, the number of students participating, doesn't pop up. So then we get into some, data exploration. We open up our attribute table. Why is it not working? We see numbers. They should display as quantitative data. Unfortunately, right now, and we can tell this in a couple different ways, our fiscal year data, so the number of students participating, is stored as a text feature. So it's stored as a text data type. So it's left justified when it's text, so it's stored the same as you would store a state name. So instead of reading it, the GIS software reading it as a amount, it's reading it maybe as a coded value or something. In your book, use the field calculator, and we'll be using it again to change the data type so we can display it as numeric values. You could also check, if you weren't, the justification can be hard to remember, but if you go into the field information, you can always see the data type in this column here. So if we scroll down, we can see all of these are text types. So what we'll do, like we did in the book, we will create a new field. just going to make it 2020. Numeric data. I'm leaving it as a long data type. Talked a little bit in class about the different data types, different numeric data types, but the long will give us whole integer numbers. Change the number format to numeric. I don't want any decimal points. You don't have to do all this now. Sometimes it's just easier. And we want those 1,000 separators in there, so it'll make it easier to see. Then we click Save. And we have now, at the end of our attribute table, our new field. So from here, we can go to Calculate Field, and we can tell it we want this new field to represent, let's make this larger, or we want to use what's in the fiscal year 2020 data as a text, and we just want to convert it into the numeric form. So we'll just go ahead and double click on the field we want to change numeric and click Run. And we'll see now we have our values that are aligned or right justified, and if we go into our fields information, we'll see that this is a numeric data type. So now we can go to our symbology. Oops, I just closed that map. That wasn't, well, if you ever do that, it's here under your maps. Just double click it and open it back up. Okay. So now we can go back to our symbology, change it from area of land to that numeric value, and we can see that we have displayed in our natural breaks classification our average number of students using the school lunch program in 2020. One thing to keep in mind, the classes that we're seeing here are going to be different across all of our data, all of our data years, and across all of our classifications. So whatever method you're choosing, in the book it talks about how to import symbology from different layers, but in a way that you will keep the symbology from one layer and keep the divisions from one layer and apply it to others. But our natural breaks classification, that's one where it's just looking for natural gaps between numbers. If we lined up all 56 values, where we would find different breaks in the data set between values. So, you know, oh, I'm in the numeric one, that's why I'm not in the numeric one, I should say. So we can look at, you can kind of just start to see, we have 5 classes, we're going to have 5 breaks, and they set the first break at 198,000, so let's see what happens there. So they're saying this break between 198,000 and 211 is significant enough to add a break in, and then you'll see another one. Yeah, this one's pretty obvious. Oh. Well, this big break between 413 and 415, that's where they're putting the other break. So it calculates it for you on your own. We can also move to a different classification system. We can check out Quantiles, which is distributing observation equally across a class interval, giving unequal classes widths, but the same frequency of observations per class. So this won't be equal between, the distance between 65,000 and 234,000 is going to be different than 240,000 and 364,000. But we have the equal number of states in each class, so there's about 10 that we looked at. Equal interval is another popular one, where this method is taking the difference between the low and high values of a distribution and dividing it equally, dividing the difference into evenly spaced intervals. So we have a high value and a low value in our data. They're going to subtract the two and come up with the cut points. So the cut points end up being at about 500,000. 550,000 or so. So you can let's see what we're looking at there. Actually, it's 530. Anyway, it doesn't matter. You're right around 550,000. So with equal intervals, you may have empty classes, which we're seeing here. We only see 1, 2, 3, 4 shades, at least in this view. I don't think Hawaii is significantly different. But this is great if you wanted to highlight some outliers. So we can see that, California and Texas are really standing out as the most students using the free lunch program. Whenever we look at population data, we get into our other topic from this week, normalization, which is when, instead of looking at raw counts, we are going to normalize the data, or maybe turn it into a percentage or a proportion or something to get a better understanding of how the states actually compare. Because right now, all we're really looking at is a population map, or where there's a lot of kids enrolled in school and getting the lunches. So it's really just showing there's a lot of kids in these darker states versus a lot of details about why more students in certain states, or the percentage of students in certain states. So we may see a state that has really low raw number, but it's a high percentage of their students. So what we can do is we can go into some data normalization and look at how to compare our data sets to different data sets that may be influencing what we're seeing here. So this is the same data set we were just looking at, just in black and white, and in a different, we're in natural break, so let's go back to equal interval. We can take a look at the histogram too to help us with, I forgot to mention the last one, you can create a histogram and look at that to help you with, understanding where kind of data you have and where you should put the breaks in your data. So you can see this really large break here. But anyway, let's get back to what we're talking about. I forgot about that. So what might this be related to? Right now, like I said, we're just seeing, raw counts. We can compare this to, I was thinking population under 18. So which states have high percentages of people under 18 that live there that might be taking advantage of the free lunch? And I thought I should really, after I did this, I thought maybe I should do this for 5 to 18, but this is what we're working with. So this is, again, just census data, population data, and I used the graduated symbols. And we can switch it if we wanted to equal intervals to really see those outliers. But again, see that the patterns that we're seeing are pretty similar to the patterns that we're seeing for the number of kids under 18 and under are very similar to the patterns we're seeing for the numbers accessing free lunch. So by normalizing the data, by saying, okay, we want to just simply normalize the data, we want to divide the number of students getting free lunch by the number of students under 18, number of people under 18, sorry. And I have the metadata for this. You can understand what all these categories mean. But again, the problem is I am looking at the wrong data set. So we can normalize. Okay, so let's go. Hang on, let me pause and set this up. Okay, so we have our same map that we saw here, looking at the 2010 data, 2020 data for the number of people using the school lunches. So we can divide that by our population of people under 18. We can do that just by looking at symbology. So not actually creating a new field like we did in the other example, just looking for our field we want to use to understand the percentages. So here we're still looking at equal intervals, and you can see the percentage breaks of where there are a high percentage of people accessing school lunch as compared to the population of 0 to 18-year-old people in that state. Gives a really different picture from what we saw before. We still are seeing a lot, we're still seeing, the second and fourth, or the third and fourth classes for Texas and California, but we're seeing some other states really pop out in terms of the number of youth there. So this is saying a high percentage of youth are using the free lunch program in these states, where in other states like Washington, Nevada, Colorado, Maryland, are you having lower percentages of students accessing the free lunch program, the federal free lunch program. So we could get into a lot of questions about why we're seeing these patterns. We could pull additional data. I pulled some median income data, so we can look at compare median income to the percent of students participating. So we can switch this to, let me change this to graduated colors. Okay, so here we're seeing that same comparison between or a different comparison, I should say, the number of students in the lunch program, just the raw counts, and we can compare that to the median income. So higher median incomes are going to be larger bubbles. We can put this down to 3 classes if we wanted to really see the difference between the states. And we can see, higher incomes, median income for the state, it doesn't have an influence on how many students are getting the free lunch. We can also turn off the normalization. Well, we could leave that normalization on and see, again, the median incomes compared to the greater percentage of students, people under 18, accessing the school lunch. We can try to make some comparisons. It might not be that helpful, but it's, a place to start. All right, so that's sort of what I walked through, everything related to what we've looked at in class, exploring our data. Let me know if you have any questions.